Welcome to this customer request tech tip provided by Imaginet Technologies. My name is Rusty Belcher and I'll be working through the tech tip with you today. Now in today's tech tip, we actually have a customer request of how you would use surface data generated in another CAD package as a functional part of your Inventor model. In today's example, we're going to be working with some boat hull information that was initially generated in Rhino. We're going to bring that into Inventor and use it as a functional part of our design. Now the first thing we want to do for our demonstration today is import the surface into Inventor. Now I've worked with this surface prior to recording this demonstration, and I found that the surface is not completely watertight. So when we import it, we're going to need to fix that before we use it as part of our model. In Inventor, we use the open command as import, and you can see that I'm going to bring in my Rhino file here, but I just want to expand the available file types that are available for import into Autodesk Inventor. And you can see that just about any major CAD system is supported as an import option for Inventor. So here's my Rhino surface. I am going to select options prior to import, and I want you to see that I've chosen to import this into my repair environment. That's how I'm going to make the surface watertight before I use it in the model. We'll go ahead and select open, and immediately we run an analysis on the surface, and we do find some warnings as far as healthy geometry and geometry that requires a repair. Now I do want to show you where the non-watertight area is, and to do that I'm going to remove the translucent option from the surface, and I'm going to rotate this around, and we're going to zoom into this little area right here. Now this is just one of the areas I found that we actually have a non-watertight surface that we need to address before we use this as part of our model. There is a very quick test we have to find the errors in the design, so I can simply use the Find Errors command, select everything, and click OK. And in my browser you're going to see my modeling uncertainty errors and my intersecting face errors. We have a very nice option to heal those automatically, so I can come in and again select everything with the given tolerance. We'll go ahead and fix that, and you can see that it removes almost all of the errors I had. Now the surface is still not watertight. If I were to zoom in, you'll see that the little opening is still there. So fixing the errors doesn't make it watertight, but it does ensure that we're using good, valid surfaces from this point on. Now to make the surface watertight, I'm going to use the Stitch command. Now with the Stitch command, I'm simply going to select all of the surfaces in our design, and I'm going to define a tolerance. Now for this example, I'm going to use a pretty large tolerance because I want all the gaps to fill up. If I were to use a smaller tolerance, let's go ahead and try a smaller one first. And we'll do an analysis of this. And you can see the red lines that are on the inside boundary of the surface, and these all represent unstitched edges. So I'm going to bump up my tolerance a little bit and rerun my analysis. And you can see that now all the surfaces inside the boundary of the surface are stitched together correctly. We'll click OK, and we now have what I believe is a good watertight surface for us to use going downstream. And again, if I were to zoom into the same area we had before, you're not going to see the gap in the opening of the surface as we did before. So now that my surface is watertight, I can finish my repair, and the surface is now part of the model. It's a nice healthy surface that we can use as part of our design. Now moving forward, I want to turn on the translucent option so that I can see through the surface as I begin to generate some of the models or some of the model data. Now for this example, I only have the surface for the starboard side of the boat. So everything I'm going to model is going to be inside of this starboard surface. Now if I had the surface for the entire hull, everything I'm about to show you would apply to the entire boat instead of just the starboard side. Now I'm going to draw a line that represents the deck of the boat. To do that, I'm going to start my sketch tool, and I'm going to sketch on my XY plane. We're simply going to draw a line That represents the deck right there. We'll select Finish Sketch, and we'll go out to our isometric view. Now I can use the Extrude command to extrude the line. And I can drag it any distance I want, but for this example, right about here will be good. So this basically gives me a surface, and Inventor is a fantastic surface modeler. There's a lot of nice things we can do with intersecting surfaces like the ones you see on the screen. I'm going to use the Trim Surface command, and in this case my cutting tool will be the hull of our ship. And then I can select the part of the surface that I want to remove, and in this case I want to remove the outboard material. So what that leaves me is a surface that's perfectly conformed to the inside hull of the ship. Now I want to draw a few frames. Now I'm going to sketch now on this new deck plane that I just created, and I'm going to add a few rectangles here. Now I'm not going to measure these precisely. This is just a very quick example to show you what is possible. So I'm going to draw a rectangle, and I'm just going to make these 0.25 thick, and I'm just going to drag it out to about right there. I'm going to drag a few of these over. Again, I want to make sure I stay inside the boundary of the surface. So now that I have my rectangles, I can extrude these to solid objects. We'll use the Extrude command, and I'm going to come in and select these loops or these profiles. Now, as I extrude these, I have some nice options. I can actually, instead of using a distance, I can extrude to a selected face or point. And for my face, I'm going to select the surface of the boat. And you can see how that extrusion is going to conform to the surface. So I can do all of my frames for the boat very, very easily using the surface that initially came from Rhino. I can also sketch on our deck and then extrude that upwards, making a solid body of that as well. Now to finish up our example, I want to model a locker that sits on the deck and also conforms to the hull. Now to do this, I'm simply going to draw a rectangle on top of the deck where I want the locker. And again, the rectangle is going to pierce the surface of the boat. Let's go ahead and start our Extrude command, and we'll simply drag this upwards. I do want to make sure that this is a new solid body, and again I want to make sure that it stays inside of the hull form. Now when you're dealing with solid objects, you can use the surface data as a cutting tool. I'm going to start the Split command. The Split command prompts me to select a cutting tool, and in this case that's the surface hull. I can then choose the option here to trim my solid, and this is the solid I want to work with. And if I click OK, you can see how the part immediately conforms to the surface. So this will conclude our demonstration for today. I hope you've seen how we can take surface data from just about any CAD package, import it into Inventor, actually fix some of the surface data, and then use that as a functional part of our Inventor design. If you have any questions about the contents of this demonstration, please contact your Imaginet Technologies support representative or your account manager.